Well, thank you all so much for joining. Welcome to the RStudio Enterprise Community Meetup. I'm Rachel Dempsey. I'm calling in from Boston, and I'll be your host for today's meetup. And I'm so excited to be joined by Job and Sjoerd today. But if you've just joined now, feel free to introduce yourselves through the chat window and say hello, maybe put in where you're calling in from. But just to go through a brief agenda while we wait for a few others from the waiting room, we'll go through some introductions of the meetup, have a great presentation on the Clusterbuster app and the organizational aspects of putting that into production with Sjoerd, and then how to build a production Shiny app, some of the more technical aspects from Yab, and then a fun Ask Us Everything open discussion time for you to ask anything that's on your mind about presentations and Shiny and production in general. Just a quick note that the recording will be shared up to the RStudio YouTube. So you can always ask questions anonymously through Slido if you don't want to be part of that recording as well. But I will share that Slido link with you in just a moment. You can upvote other people's questions too, and that will help us organize the questions. One other Zoom note, if you want to turn on live transcription, you can do so during the talk as well. So in the Zoom bar below, you could just press more and turn that on. And I see that a few people did, so awesome. For anyone who's joining for the first time, welcome to the RStudio Enterprise Community Meetup. Just to kind of let you know what this group is. This is a friendly and open meetup environment for teams to share the work they're doing within their organizations, teach lessons learned, network with others, and really just allow us all to learn from each other. So thank you all so much for making this a welcoming community. We really want to create a space where everybody can participate and we can hear from everyone. So just like to reiterate that we love to hear from everyone, no matter your level of experience in the field or the industry that you're working in. I'll share a few links towards the end of the meetup if you ever want to give suggestions or general feedback on the meetup, or if you may be interested in speaking at some point in the future too. We'd love to hear from you. But with that, that's enough from me, and I'd love to turn it over to you, Sjoerd, for the first presentation.
Thank you. All right, so this is my first presentation on the Clusterbuster in English. So if you see me struggling for words at some point, please forgive me. Give me a couple of seconds. I will figure out a way to put my thoughts into words eventually. So I'm here to talk about the Clusterbuster, which is an application for the surveillance of COVID-19. We made this for the RIVM in the Netherlands, and I'm going to talk a little bit more about the RIVM and what that is exactly. But mainly I'm going to talk about the process to creating valuable insights with RShiny. So let's see, I can move these windows around. So first of all, a little introduction about myself. My name is Sjoerd Wierenga, which is Dutch name, hard to pronounce, so you can call me Sjoerd if you want to, that's no problem. I studied public administration about a decade back, worked in healthcare for a couple of years, and finally decided that I wanted to learn how to program. So as you can see, I am not an epidemiologist, I'm not a doctor, so I'm not going to talk about the virus, about COVID or Omicron. I'm going to talk about the application and how to get things done within the context of the organization that I worked in. I started working at the RIVM a little over a year ago. It was Tuesday, December 1st, 2020. So it's not too long ago, but to be honest, it was a weird time. So it feels like a century ago. Little summary, introduce myself, what I just did, and the RIVM. I'll talk a little bit about that. I'll talk about an intriguing yet slightly abstract question that I was being asked in December of 2020, the context within which we operate, and the approach that we took to produce value fast. Well, that's a relative term. Let's say it was fast. And then the final bit, I need to move the screen around. We'll talk a little bit about the results of our efforts and maybe give you a sneak preview into some of our following work. So I practiced this talk a little bit with my colleague Jap, who will be talking later on. And I noticed that I had too many slides. So I think I have 37, 38. So I'm going to skip over them pretty quickly. They will be downloadable at some point. Rachel will probably share a link to that. So if you have any questions, just ask. Yeah, so maybe I'm going a bit too fast. So if you have any questions, just ask.
Yes, and we can share this link to the slides with the recording, which will go up to YouTube as well and on the meetup.
Perfect. All right. So what is the RIVM? It is the National Institute for Public Health and Environment. It's part of the Dutch government, and it houses the Center for Infectious Disease Control, which is the Dutch CDC, I guess you could say. There we have the Department of Data, Innovation and Signaling, where I work. And then finally, I was allowed to form my own team, which is Team Clusterbuster, which I'll be talking a little bit more about later on. As I said before, I want to start off with the slightly abstract question that I was being asked in December of 2020, which was, can we help municipal health services gain insight into data concerning the clustering of cases? This is one of those questions that you need to really ponder on a little bit to fully understand what's going on here. So I had a lot of questions when somebody asked me this. What do you mean exactly by municipal health services? Who do you mean? There are a lot of doctors working there, epidemiologists, but also researchers, policymakers, decision makers. Who are we referring to when we say we want to share insights with these organizations? Gain insight into data, like what kind of insights do you mean? What kind of data do you mean? What kind of data do we have? And what do you mean by the clustering of cases? By cases, do you mean some mathematical approximation of the amount of COVID-19 that was circulating, or do you mean reported cases? So as you can imagine, there were a lot of questions for me to ask during the month of December 2020. So that's what I started off with. So I said, well, I am very intrigued, but I need to ask a lot more questions to fully understand the problem here. A little bit about the context. I was talking about this municipal health services. I don't know if you have something equivalent to this in your country, but we have 25 of them in the Netherlands. They cover certain areas, certain municipalities, and they are at the front line of fighting COVID-19. There are a lot of doctors in infectious disease control working there, epidemiologists, and they are responsible for testing and vaccination in the Netherlands. They also have a local advisory function. So it does happen that sometimes an organization is closed because they refuse to adhere to the national guidelines. And these MHSs, these municipal health services, have an advisory function on that as well. These 25 regions are subdivided into 7 regions. And let's be honest, they've been in crisis mode for close to 2 years. And I think that is a very important observation also concerning this talk. So this is the Netherlands. You all know this. This is the 25 municipal health regions. And this is where the Netherlands is situated. I believe you are in Boston, right, Rachel?
I am, yes. But I see people are joining from all over the world.
Everywhere. I was expecting a lot more American, but it's really all over the world. So, well, you'll probably know where the Netherlands is. If not, I refer you to Google Earth. So let's start off with the approach now, which is, I guess, the most important part of this presentation, but a little disclaimer to begin with. You have this saying, under pressure, everything becomes fluid. We use it a lot in Dutch as well. Onder druk wordt alles vloeibaar, we say. And I put this at the start of of the main part of this presentation because this is not a normal organization in COVID-19 times, and this is also it's not a normal era, so to speak. So I was thinking, what is it that I want to share in my presentation? I want to share something that you can actually take with you to your organization, also in normal times, because a lot of things were different now. There was more money to get things done. There was less bureaucracy, etc. But keep this in mind as I continue my talk. And I tried to really focus in on the things that you could take with you to your organization during normal times, hopefully very soon. So as I said before, I was faced with a problem and I really wanted to understand this problem properly before continuing. So I wanted to have a clear view of who our customers were, which is not a term you hear often in the public domain organization, but it's really relevant. Who are we working for exactly? Is it the decision makers? Is it the researchers? We decided that it is actually the doctors and epidemiologists that work at these MHSs that we want to inform. So we had a clear definition of our customer. What kind of data do we have? Well, we have the source investigation and contact tracing data. So anytime you test positive for COVID, you will be called by one of the employees of the MHS when you live in the Netherlands, and they will ask you, where have you been? Who have you been in contact with? Where do you think that you may have contracted the virus in all likelihood? And this data is being sent to the RIVM, and we use this to create, well, let's say actionable insights. This was at least our wish from the very beginning. We want to not just create insights on things that people want to know, but there need to be some action tied to the insight. The doctors and epidemiologists in the MHSs, they advise the executive branch. So we wanted to give them the insights to have as good as an advice as possible to eventually, this was one of the goals, bust clusters. This is what the woman that hired me actually told me, that they wanted to go busting clusters. So I was like, what does that mean? This is actually an epidemiological term. And I thought to myself, that is a great name for an R-Shiny application. So I kept using that. And eventually, when we went to production and started opening our application to doctors and epidemiologists, I was like, maybe we should find a more formal name for this application. But this doctor I spoke to said, no, you definitely need to keep it called the Clusterbuster, because that is a great name. So it's been called the Clusterbuster ever since, and I'm very happy that we stuck with it. So this is an example of what happened in the Netherlands. I believe this happened in the US as well. This is a meat processing plant that was shut down because there were too many positive COVID tests reported back to this facility. They were not adhering to the guidelines, so this one got closed. This happened over 200 times, I believe, in the Netherlands in 2020. So giving advice on where COVID clusters is actually a really relevant thing to do. Another part of the problem is not all 25 regions had proper access to actionable insights. This was obviously a main part of the problem. They did not have the insights. They did have the data because they collected, but they did not have sometimes the analytical talent or the tools to come up with insights that were valuable. So some did. Some had great tools. They had great dashboards. There was already an R-Shiny dashboard produced in one of these MHSs. Some had great reports. So one of the main questions that we asked ourselves is, what are the best practices that we see in these MHSs, and can we replicate them, and can we redistribute them to all 25? So that was one of the main goals we had in mind. To do this, I first had to have a clear understanding of whether or not it was possible to share insights. And obviously you have some prerequisites when you want to do this. You have some legal boundaries. We cannot share all the data. You have GDPR, privacy regulations in every country. I believe everyone in this meeting has their own version of GDPR. We had as well. So there were some boundaries and limitations to what we were allowed to share. Obviously the data had some limitations and the technology had some limitations. So I needed to have a clear understanding of what our limitations and possibilities were. But once I had this understanding, my advice was actually to move forward with R-Shiny. So I use this metaphor a lot, but it was a little bit of a 100-meter hurdle run. Like, what are the hurdles that we need to pass one by one in order to get to our final goal? So do we have legal hurdles? Do we have technological hurdles? Do we lack some data, but can we get it? These are the kinds of questions that we asked ourselves in the very early beginning. So finally, I said, yeah, well, I think R-Shiny is actually the right tool for the job. And it was actually a logical choice in my view. Why? Because a lot of the data preparation, COVID-19 data in the Netherlands, was already done in R. A lot of people working at the RIVM are familiar with R. And there was already some experience with R-Shiny applications. So based on my prior experience and my first weeks of investigation at the RIVM, I knew for a fact that we could produce value with our Shiny. But this was just me. Our Shiny is still quite a new tool, although some of you might disagree, but for organizations, it's still at some point quite new. So I had to do some convincing. So what I did was I created a prototype of which you see a screenshot here. And I use this to show that our Shiny can actually produce great looking and valuable dashboards, valuable insights. This one is still online, and I guess I can probably share a link to this at some point, maybe later on, Rachel.
Yeah,
so
definitely.
People can look at it themselves. Yeah. So yeah, it's probably most fun if you can just click through it yourselves. But I created this prototype because I still needed to convince some people that our Shiny was actually the right tool for the job. And this is highly recommended. Yeah, they got really enthusiastic. So eventually I got the green light and they said, well, Sjoerd, we trust you. Yeah, let's go for it and create a team. Do whatever you think is necessary to create this application and share insights with these MHSs. So I got the green light to build my own team. I wanted it to be as vertically integrated as possible. I wanted a team to be able to produce 80 to 90% of the application all by itself. Obviously, some of the work is too specialized to do within your team. So we had to rely on the IT department a bit as well. Job will talk a little bit more about that later on. We were meeting very often. Well, let's say 3 times a week, we had a daily stand-up meeting, and we would be meeting in between those, obviously, pretty often. So we had a sort of an agile working style. Let's say it was rapid iteration. It was not agile to the T, but it was agile in spirit. And there was a lot of enthusiasm. I think this is really a result of vertical integration and working in an agile way, because we were capable of doing so much ourselves. At some times we got a request for an insight and we could deliver the same day, and that is a great way of working. This is also thanks to our Shiny in part, and to the special skills that we had in our team. So this vertically integrated way of working really helped us and made us very enthusiastic in the process. So this is our team. I stole this picture from Job. I believe he drew it himself, which is amazing. I didn't know that he had that talent as well. But this is our team. We're 7 of us right now. But we started off with a very small team with myself and Yossi. She is my colleague that is responsible for the coordination of doctors and epidemiologists that work at the RIVM. So we started off with Yossi, with Job, and with myself, but we gradually built towards a larger team, and each and every one of them had their own part to play. So this is the team, 7 people, but I think all in all, it's probably 2 full-time employees. It counts up to 2 FTE that we used to create this product, which in my view is still really quite amazing that we were able to do so much with so little. This is probably quite a convincing argument for decision makers in your organization as well. So January 2021, there was some understanding of the problem. The prerequisites were met. We had our weapon of choice, which was our Shiny, and there was a team. So now what? We were all ready to go. But yeah, what was the approach? And I think that this is the single most important question in this entire process is how do you allocate as much of your energy as possible towards creating value? And obviously, to be able to do this, you need to have a clear definition of value. And as I said before, I am not a doctor, nor am I an epidemiologist. So nor am I an end user of the application. So we said to ourselves, we need some sort of a feedback loop from the users themselves, from the experts themselves. So we put together an advisory board, Yossi and me, containing of doctors and epidemiologists that work at the MHS. So they were the representatives, so to speak, of our user group. Together with them, we had a strong focus on actionable insights as much as possible. Obviously, sometimes you create an insight just because it provides some background information that's useful in getting a situational awareness. But we were definitely focused towards creating insights that could lead to some action in practice, and not just a nice to know thing. For me personally, my most important role in this advisory board was balancing between requests and possibilities. So oftentimes the advisory board would put down a request, Sjoerd, is this something that you can make? And I would balance this out with legal possibilities as well as technological possibilities. And we would have weekly meetings with this advisory board. So here you can see this rapid iteration, weekly meetings. We would provide feedback on Fridays on what we did, and we would continue to look forward at trying to find new insights that we could produce that would help out even more. So this is one of the sentences that I show to this advisory board every week. This is the task of the advisory board. It is in Dutch, but it doesn't really matter for now. What it was is it was a constant reminder that we had to work towards creating valuable insights. So very strong focus on that. Let's not waste energy doing things for fun. Let's work towards insights that actually add some value. So this is the structure that we end up with. All the way at the top, you see our user group. They are represented by the advisory board. And through the advisory board, we collect requests. The development team collect requests, and they start working on realizing those. And obviously, in the background, there's a lot of specialists that helped us out with, for example, legal questions or IT-related questions. So yeah, I think all in all, just around 30 people maybe helped us out with what I said, legal and IT matters. So what did we end up with? We ended up with an application, an our Shiny application that provided insights into vaccination. So what you see here is a map with the vaccination rate, I believe it's called, for every neighborhood and every age group. And we also combined this with the amount of positive reports. So this is a bivariate choropleth map. So you have the bivariate part is the vaccination rate versus the amount of infections in the last week. Everything you see here obviously is fake data. We had some tables. I'm not going into depth to all of those. This is a visualization of clusters. So on the left here, you see some of these clusters. This could be a workplace maybe, or a school or a nursing home. And if you clicked on one of those, on the right, you would see where the linked clusters were situated. So this is one of the requests that was put forward by the advisory board. And thanks to our Shiny, actually, we could realize this. I'm not sure if we could have done this in any other tool. For us, it was really relatively easy to create these kinds of insights with our Shiny. So I seldomly had to sell a no to a request from the advisory board, which was a nice way of working. Yeah, we used Spark lines. Job will talk a little bit more about the packages we used to create all these insights. So finally, we had a pretty cool application. We thought it was very valuable, but obviously this didn't sell itself. So I had to give a lot of presentations. I think I spoke to almost every region in the Netherlands. I've had some newsletters with regular updates, and obviously we are doing a little bit of work on outreach because we don't think that the product sells itself, so to speak. So there was a little bit of technology push, if you can call it that, but eventually we started noticing that a lot of people started asking for authorization. So all in all, now we have almost 400 doctors and epidemiologists that use our tool. So that's what we did in the meantime for the last couple of months, let's say the last 10 months already. We have been producing insights. We are approaching 400 users, and they are from all 25 MHS regions. So this is something that we're actually pretty proud of. We know that the application is being used. We know this because we track it quantitatively obviously also we ask it to the MHSs, how do you use it? Why do you use it? And what can we improve? I literally call them or send them an email to get some qualitative feedback as well. They use these insights to stay up to date on COVID-19 clusters, and they have also used our application for the allocation of mobile vaccination units. So they have a limited number of mobile vaccination units, and one of the questions they ask themselves, obviously, is what is the best place to locate this mobile vaccination unit, which could be a bus or something like that. And they use the Clusterbuster to find the optimal spot for that. And one of the nice how do you say this, side effects was that the data quality actually improved because the MHS started using the Clusterbuster. So they finally saw the reason for keeping track of all different types of data. We gave them back insights, and this motivated them to really pay attention to the quality of their data. Yeah, well, I put this in. This is just to say that we are already working on our next application. This is one that I hope that we will release, let's say, in the next month or so. And this is we will take everything we learned from the Clusterbuster and put it in our next application. This, I hope, and we are working towards this, is going to be open source. So I'm hoping to share the code behind this application, so all of you can see how we did this exactly, and can create your own tiny new Clusterbusters for whatever use you prefer. So main takeaways for me, I guess the most important ones are: have a very clear understanding of the problem, which I talked about a lot before. Create a convincing prototype. If your organization is not already used to using RShiny, especially for a public use, create a convincing prototype, or just show what we have made. It's ready for your use, I guess. Vertical integration helped us out a lot because we could create insights very quickly, so rapid iteration was possible. Very important to have a clear definition of value. So for us, we had our advisory board. I say here clear-ish definition of value because what is valuable may change over time. So at first, we said that it would be very valuable to have insight into clusters of COVID-19. This is still valuable information, but at some point we started focusing a little bit more on insights into vaccination data. So the definition of value may change, obviously, over time. Incorporate your user feedback. Keep a strong focus on what your definition of value is. I noticed that it's important to promote your product. Don't think that it will sell itself. Well, it might eventually, but really do some promoting. And ask why a lot. This may be particularly necessary if you work in the public domain, where it's not always just about efficiency. So you need to ask why a lot. Why do we do this? And finally, for us at least, I think that RShiny was an excellent choice, especially because we got to develop our insights as close as possible to the wish of our end user. And I think that is very valuable. And this is what got us so enthusiastic in using RShiny. So I guess that's it. Yeah, that was my last slide already. Was I?
Thank you so much. Yes, that was perfect.
Great.
I see a lot of great questions coming in already as well. So I'd love to cover a few of those too.
Sure. Right now?
And I see a lot of clapping by everybody. Although you can't hear us, we are clapping.
That's nice.
One of the most upvoted questions so far was, when you first introduced Shiny, what other tools were you comparing it to? Standard BI tools? And how did you explain the difference to your leaders?
That's a really good question. I was comparing it to Tableau, Power BI, all the tools that I knew. And for me, I also already from the very beginning had a clear focus on RShiny because we were working so much with R. So it was a very logical choice for me to investigate. So in that sense, it was already, RShiny was in the lead already because we were doing so much with R. Yeah.
Thank you. I see a lot of other great questions coming in too. And one that I see, Jacqueline, you just asked one. Would you want to ask that live? or I can read it too. But the question was, what were the most important aspects of your prototype app to create buy-in?
I'm sorry, come again?
Yep. What were the most important aspects of your prototype app to create buy-in?
Right. So I think that the overall looks of it and the swiftness, how would you say this? Like the visualizations that were in there all worked really smoothly, I should say. So the overall user experience was, I think, good. And this is something that not everyone was expecting from our Shiny. That is because it's still quite new, and sometimes you see tools that are not that flashy or shiny looking. So I thought it was really important to make something that people instantly got a feel for, that they wanted to work with it. So looks were actually really, really important. It's not so much about the technological aspects of it, like, oh, we can use these packages and it will all be fantastic in coding and whatever. No, I wanted to convince them by just making something that looked really cool. It's maybe a bit simple, but yeah, that was important.
Yeah, I loved the marketing of the app that the team did, and just like thinking about naming our applications too,
Yeah,
having fun names for them.
yeah, and yeah, exactly. So imagine that you're a doctor or an epidemiologist during this crisis, and um, you work 60 hours a week, 80 hours a week, I don't know, and then you are asked to use an application that just doesn't look good, it doesn't work, it's slow, whatever. This is the last thing that you want. You really want to create an application that people would want to use, even if they are working 50, 60, 70-hour work weeks during this crisis. So yeah, that was not just important for prototyping, this was important for the use of the application.
Definitely. I see a lot of other great questions that also touch on some of the technical aspects. So I may wait until we get to Yav's presentation, and then we can ask some of those at the end too, if
Perfect.
that sounds good.
Yeah, perfect. Yeah.
Perfect. Well, thank you all for putting those questions in there too. Just a reminder to anyone who joined, I'll share a Slido link again, but you can ask questions there with your name or anonymously, and you can upvote other people's questions too. But with that, I'd love to turn it over to the next presentation with Jaap, who will go through some of the more technical aspects of actually putting this Shiny app into production.
Give me a short introduction. I'm Jaap Spijker. I'm a geochemist at the National Institute for Public Health and Environment. I work at the environmental department. And I already work with R for, I think, at least 20 years or something. I do a lot of data analysis with R. And the last years in our division, we already had to put out some Shiny applications on the internet. We use Docker technology for that. That was the reason that Sjoerd asked me for this project, because he needed some backend engineer to do this work. So although I'm a data scientist, I wasn't called for my geochemical knowledge because that wasn't needed, but mostly for my engineering skills. So that was my role in this in this team. Well, Sjoerd already told something about the municipal health services. They collect a lot of data from you. Let's consider that that's you somewhere there having a COVID test, and they collect your name, your address, your phone number, your social security number, if you are affected or not. And if you are affected, they do a source investigation, a contact tracing. They ask about your whereabouts, the people you were in contact with, etc. And they also collect data about your vaccination. So that's quite a lot of sensitive data about you. Now, this is us. We are a data science team. And our assignment was a little bit rephrased than what Sjoerd told us, but they asked us just fill with that very private data, create some information out of it, put it on the internet, and make sure only people who are allowed to see it can actually see it. And this is actually the moment you have to get out of your chair, because you start yelling at us. Because as data scientists, how can you be sure that that very sensitive data is in our good hands, and that we have enough knowledge about security to make this application actually secure? So actually we had, from an engineering point of view, we had three challenges. First, we had to create this information. We had to create the dashboard, which was the least of our concerns. You have to work with all the privacy issues. In Europe, you have this GDPR, the General Data Protection Regulations, which is very strict about privacy. And we're talking about medical, personal medical data, which is the most sensitive data that we have. And we have to do a privacy impact assessment. We have to talk to our privacy officers. And that's a lot of paperwork. And part of the paperwork is to describe how we physically, in IT terminology, secure our data. And we are data scientists. We're not security experts. So this was the biggest challenge. Before I go into how we solved it, I'll show you a little bit about the data flow that we have. Here we have the landscape with all these municipal health services. They collect all the data, and part of the data they send to the RIVM using a myriad of systems. There are about 8 different systems within these MHSs. This data is collected in a database or 2, and then we have our own data science team, it's at Sjoerd's department, which actually extract the data from these databases and create all kinds of data products, reports, graphs, visualization, whatsoever, which are used for combating this COVID crisis. And all these data products are stored on a network file storage, and we take it from there. So this is from the backend side. Now, if you're going to look to the other side, this is how you want to make this data available again to the MHS. We decided to create this application using a Docker environment. We use an OpenShift Kubernetes environment for that. And what we did is that we said, all right, we put this web application in a DMZ, which is an open a piece of our network which is open to the world. And we use our F5 proxy server for the authorization. And the biggest advancement is that this proxy server was a building block, a service, which was provided by our IT department. So they were taking care of the authorization. And it means that the people at the MHS can log in using their own credentials. It's like logging in using a Google account to some other website. So logging with their own credentials, passing through the proxy, and then having access to the application. And also the thing what we did was that if somebody logs in, then we know which user it is. So then we, based on the username, we provide the user with only the data which is he or she is allowed to see. It means that if somebody makes an error here at the MHS and authorize somebody who is allowed to log in, but we haven't received any message or we don't know him, then it will the person will get access to the application, but don't have access to the data. So in case of a data breach, first, it means that this application isn't accessible if you don't have an authorization. So if you are some bad guy somewhere who wants to do something with that application, it means that you don't even come near it. However, if you can get near the application and start hacking around, it means that you only can have access to the container environment and to the data contained in that container environment. The internal data, the file storage, it was completely blocked off because there was a one-way firewall between it. So the only thing what we could do is push our data through the container, and it's not the other way around. But this was one way to also secure the data. And these were all services or building blocks or tools provided by the IT department, and also stuff which the IT department could maintain. So we can deliver an application, and we still can trust on the experts of the IT department securing everything. Now, if you look at the total picture, let's first have a look at how we at our own process. What we did is that we had this information created by the data scientist team on this network, and we had a small Linux virtual machine, running all kinds of cron jobs and doing the data preparation. In the beginning, the machine was doing quite a lot of heavy lifting on the data. Nowadays, a lot of this heavy lifting is done by the data science team, and we only have to do some small adjustments to the data. But on this machine, a SQLite database is created, and this database is pushed through this one-way only firewall onto the container platform, which is running Docker containers, and these Docker containers contain the application. And of course, we use a Git repository with the code, and these combined is this complete application. So this total picture of how we created this architecture is that we have our data science teams who are doing the first step in the data preparation. Then it's our team who's actually creating the databases and the application. But by launching the application and making the application available to the outer world, that's done on this container platform, which was managed by the IT department. That means that we can focus on creating an application while all the security issues are the responsibility of the IT department. And these guys, they have the right experts to make sure that only the right people can access this application. So this is how we solved our biggest issue around security. And these are all kind of building blocks which were available within our institute. It took a while to stick everything together, but now we have a environment which we think is pretty secure, at least secure enough for this kind of sensitive data. So this is a bit about the architecture. Now let's focus a little bit more on the application. But before that, I want to talk about our team. Sjoerd already introduced us. At the beginning, we were just a bunch of data scientists, but an application like this requires teamwork. So we decided pretty early already on certain team roles. Who's going to do what? In my case, I do the backend engineering, Jolien did the visualization, Sjoerd did a lot of talking, etc., etc. And also had these regular standard meetings, so we had very short communications with each other. And we also decided very quickly to put everything on GitHub in a private repository. That means the code, not the data, of course. And we decided to work with branches and with issue branches, etc. Just on like larger teams are used to do. And we created several containers for several stages of our application. So we have the development version, which is just for us developers. We have a testing version just to make sure everything works. We have an acceptance version. This is a version actually which is also accessible from the outside. The other two can only be accessed from the inside. So we can show some new things, and we have a production version. And using this kind of, well, tiered versions, it means that when we are at the moment that we want to put something in production, we are pretty sure it's solid, it works, and users are wants to work with it. Well, we chose for Shiny, obviously. But one of the things we also decided is that we are going to split up this whole Shiny application in Shiny modules. If you create any serious Shiny applications, I think you should use Shiny modules. With modules, you make it much more easier to maintain and to reuse code. I'll come to that later. But as I said, we use SQLite as a database powering the app. SQLite is very portable. It's just one single file, which is very easy to move around. And we use the pull package to access the SQLite. For the visualizations, we use HighCharts, and HighCharts is a visualization library which is almost the default for the Dutch government. It's you need a paid license for it, so it's not free. But we have the license, and you know these visualizations they just look cool. We use Shiny logs to track usage, and for the visualizations of the maps, we use Leaflet and simple features, and we also use spark lines, so our tables look pretty cool. These are the main packages. I will go into some details. First, these modules. If you look at the application that we create, the total application contains about 75 different visualizations. However, there's a lot of reuse. It means that we can create these 75 visualizations with about 25 modules. And this also includes modules for titles and stuff like that. And reuse makes it very easy that you can reuse all your code. For example, there's a setting page in this application where you can see what the affections are depending on different settings, like nursery, homes, or like schools. And these pages, they contain all the same visuals. But if you use modules, you just create one module, and you can use, and a module is one single visual, and you can use that visual on different pages and on different locations inside your applications. And also for maintaining your code, it's also very easy, because if there's something wrong with the visualization, you immediately know where to look at which part of the code is causing the troubles. What we also did is that we organized our code and what we use, what we call subscripts. If you look at the server.r file for such a huge application, it's about hundreds, maybe thousands of lines. And we just chopped it up in different sections and sourced it using a source local command. And this makes also the code more maintainable. It also means that if you work as a team, it's much easier to work with one person on a single file, because if you works with multiple persons on the same file, you have the risk of conflict. So it makes things a little bit more difficult. So that was one of the things that we also did, to split up the code and make it easier to maintain the application or to add new features. One of the things that was very important for us is the tracking of the usage of the applications. We really wanted to know how our users interacting with our applications. Of course, you can ask what they're doing, but it's also nice to have some quantitative data about it. So we use Shiny Logs as a package. And I think Shiny Logs it's a great package for that. However, there were some privacy issues with Shiny Logs. One of the things what Shiny Logs did was it was recording the IP number, and the IP number is an identifiable number which can identify a person. So, and according to our privacy statement, we cannot record it. So what we did is that we wrote some functions. So we rewrote some functions of Shiny Logs and then overloaded them in the library using the assign in namespace. So we make some little adjustments to this package without actually altering the package. What Shiny Logs does is store all the data that it has also in an SQLite database. And we created even a separate dashboard out of it, so we could just follow the user interaction. All right, these were just some details. Of course, when you're working with an application, you're always thinking, what are the next steps that we're going to do? One of the things I really like to look into is using regression tests. We are creating a Shiny application, but testing takes quite a lot of time. If you can automate this somehow, it will really contribute to your speed of coding and speed of adding new features. It's not implemented right now in Clusterbuster, but we're thinking of it to do it for next version. Also, one of the things that we want to look into the communication between all these reactive elements in such an application. We think it can be more efficient, but it's also, if you're working with it always gives me headaches. So we really have to think about it once. And also for other applications, I'm not sure if we're going to apply it to a next version of Clusterbuster, but at least for other applications we're working with, we're thinking about using frameworks like Golem or something else, just to make the development cycle a little bit faster. And we really like to make this open source. However, it's not on top of our list. We're very busy. The COVID numbers are soaring high here, so but we really like to make it open source. So maybe in the future we put it somewhere so you can have a look at it. And of course, we're also thinking about Clusterbuster 2.0, the next version of this application. So in summary, as a data scientist, you like to make shiny applications, but you have to be aware that you're not a security-oriented programmer. So make sure that somebody else, in our case, the IT department, is taking care of the security, and that they provide a safe environment, in this case, a Docker environment where you just can put in your application. So you have to really think about your infrastructure, and that means go talk to these IT people. They, especially considering security, at least at our institute, they know what they're doing. And also ask yourself, do you need all the data? If you create an application, do you need to connect that application to all the corporate data you have? Or can you just extract the only the data you need for this application? It means that in case of a data breach, not everything is lost, but just one piece of just a few data points. And the second thing is that if you make a selection, your application will be quite faster. Also, of course, modules make you happy, so please do use modules, split your code. It's very important to know your user. Sjoerd talked quite a lot about it. And what I really like is that you have to work as a team. As you start with such an application and you put some people together, go sit with each other and just talk, how are we going to do this and how do we like to work together and how do we, well, make this work. Just a little reflection on how you interact with each other. It can be very important, and it can be very fruitful to get the energy going in a team. And that's all for today.
Thank you so much. Yeah, that's an amazing presentation. It's awesome to see both sides of this too. And again, we're all clapping, although you can't hear us, if you can see in the chat. There are a lot of great questions over on Slido. So I'll start asking a few of them here from Slido, especially the anonymous ones, but would love to have people jumping in and asking questions too. So feel free to raise your hand on Zoom too. Well, one of the most upvoted anonymous questions right now is, as Clusterbuster began to be used by more people, did you face any performance issues? And how did you adjust your app to deal with more concurrent users?
Really good question, and something that we thought about when we first started. But the reality is that we create an application for professional use. So it's not the case that we have hundreds or thousands of users at the same time. Sometimes it's 10 users at the same time, for example. So, and this is not a problem for us because our impact does not fully rely on the amount of users that we have. Sometimes it's more impactful to have one doctor look at it than to have 10 other doctors look at it. So for us, the numbers don't really say that much. But because this was a tool made for professional use, the number of users was continuously low. So we never actually faced any problems in performance. And also because we are running this on the OpenShift Kubernetes platform, well, it will probably just scale up if we run into any performance issues. This is a more relevant question for following applications that we are planning to make public instead of for public use instead of for professional use.
I see another question that says, thanks for the great presentation. How did you gain the support of the IT team? Because for some, there may be a little bit of hesitation regarding Shiny.
Yeah, well, maybe. I didn't, well, I did notice some pushback, obviously. Someone even literally said to me, this is never going to work. But as long as you just stay positive and patient at some points, I think it will all work out. So also what really helped was when we showed the prototype or when we showed the application itself. This really helped. So when we talked to people and I showed the application, they all of a sudden understood what we were talking about. And this I believe was very helpful. Yeah.
Yeah, that's very important to have a very open mind talk with these IT people. Just tell them that you want to put something like the Clusterbuster, that you want to put it on the internet, and just try to think and work together how we can do this in a secure way. And at least our IT department, suddenly what Sjoerd says is they understand what you want and they are thinking with you. Hey, don't try to make them think against you, but try to find a common solution which actually works, and it's possible.
Also, maybe the crisis helped out a little bit. So in this case, it was, let's get it done. That was also the mindset. So at some points we had to just push through and say, well, we need to do this. And I guess that's different in normal situations. But apart from that, I think a good honest talk, as Job said, and showing what your ideas are really helps.
Definitely. Thank you both. Eve, I see you asked a question in Slido, and I'd love to pull in some people if you want to ask anything live. I fixed the ability to unmute yourself if you want to jump in. And the question is, can you say anything about the updating the frequency of the data, the update frequency of the data in SQLite in production?
Yeah, MHSs, they send the data to us once a day. And it's usually in the morning, and now the data science team starts in the morning with all the extraction and stuff like that, and they prepare the data sets that we use, and usually around noon we run our scripts to create a database. So it's created on a daily basis. So once a day we create a new database with the latest numbers from yesterday. So it's once a day, but if you want to do it more often, it's quite easy. You can run it every hour, but the new data is only available once a day. So
great, thank you. And I just put in the chat, feel free to raise your hand if you want to ask your question live, so you don't have to just keep hearing me reading them. But the next one was, which model was used to define the clusters?
Right. So from an epidemiological standpoint, I cannot really answer that question, but I can answer how the data got constructed. So every time someone got a positive test result, he or she was called by one of the employees at the MHSs and was asked, with whom have you been in contact? Where have you been? Where do you think it's most likely that you've contracted the virus? And once 3 or more people were saying that they most likely contracted the virus at a specific place, we would call that a cluster. Obviously, if you scale up, you would call it an outbreak or a super outbreak. And the MHSs would write down these clusters, would register these clusters, and they would send that to the RIVM. So that's the starting point for us to use for our visualizations. This was a separate data file that they sent us.
Thank you. Thank you for an awesome presentation. Can I ask you if you considered not using a database?
We have considered this. At first, different ways to go. We were not really sure what would be the best way to go. So we started out with the database and eventually stuck with it. But this is one of those things that from time to time you need to reevaluate. Like, is this the right way for Clusterbuster 2.0? Is this what you would do? I'm not totally convinced that we would. Yeah, there is something to say for using databases and something to say for using pins and just R objects. You have something to add to that, Job?
Yeah, well, the great thing is that, of course, in that database, there are multiple tables you want to use, and it's very easy to make relations between these tables. So, therefore, you use a database. Also, if you put this information in an R object or an R environment, it's for me, it's more difficult to work with. A database is such an easy object, and it's a single file, and you can work with it in R, but you can also open it in a certain SQLite browser just to inspect your data, or you can use it in also you can use it in multiple applications. It's much easier to have multiple file connectors to that database. So for me, I think I prefer a database over some file-based R object.
So one of the
maybe it's a matter of taste.
Yeah. One of the ways you could look at this is also from the performance perspective. So right now we are iterating over our database to give back the data from a specific region. This is not a very fast operation. So if you use, I forgot the name of the package, but we do monitor the performance of the application. And if we would notice that it would take a lot of time to produce the visualizations, then I would definitely consider backing off of a database. So there are multitude of considerations you need to make. So for now, it's fine, maybe because of our small user group or the amount of data that we have, but this is certainly a question that's on our mind.
Thank you. Nimish, I see you have your hand raised too.
Yeah, hi. I'm Nimish Sheth. First of all, thank you for a fabulous presentation. I'm, like a lot of people around the world, super interested in how, regardless of where in the world we're tracking COVID outbreaks and responding. I'm originally from India, and I was super interested when India had a big surge, April of last year. And I actually did some personal research into the data just to see if I was in a position where I had to intervene, at what point do you do something? It's easy when something happens and then you react to. But my question here is, I understand that you had a separation of data processing. So you had a team that took source data and did the transformations that you then ingested to work with in your application. So the question is, what's the communication? Because the upfront data engineering is going to do a certain amount of work, not guaranteeing a level of transformation that you want in your application. So is it a two-step process, or are you giving them requirements?
I guess it's a little bit of both. So I am part of the team that does the ETL using R, actually. So I was pretty up to date with what they were doing, but eventually we noticed that there was some distance between team Clusterbuster and the team that's doing the ETL. So this is where Fleur comes in. She is the latest member of our team, and she works for the team that does the data preparation, but she's also part of Team Clusterbuster. So we noticed that there was some risk of miscommunication, and that's where we decided to narrow the bonds. So this is a very, very, very good and important point you make, and something that I was very aware of. And finally, we had to take steps in order to prevent some miscommunication from happening. Yeah. This is where vertical integration is such an important part. So as long as it's possible to vertically integrate these different skills into your team, it prevents miscommunication. So this is one of the aspects where it was very hard to do so, but we eventually managed to form some link to prevent miscommunication. No.
Thank you.
Great, thank you.
Thank you.
Anubhuti, I see you also asked a question. I'll read it, but jump in if you have any other context to add. But this is a rapidly evolving disease. How often do you collect feedback from users and update your app?
Right. So I had the meetings with the advisory board on a weekly basis. So we spoke to them very often. And I work at the RIVM. I'm literally surrounded by doctors and epidemiologists when I'm there. So I'm always up to date on the latest of the latest. So how often do you change? That is a good question, because you do not want to become neurotic in what you develop. So this is where your focus on value is so important. But we did have to change a couple of times. And I had this idea that we should sort of move along with the epidemic. So at a certain point, vaccination was more important. So we started focusing on that. Right now we're at the Omicron phase. This brings in new challenges. So we have to stay flexible, but not neurotic. I think that's the most important part.
I like that. I see there's a bunch of other anonymous questions too. And one was your data loaded into Docker in a form of some aggregates? And how did you create them?
This one's for you, Joop.
Yeah, what we did is that we, of course, we had these already prepared data sets, and we made our own selections out of these data sets and then put it into the SQLite database. It's not aggregated data, it contains individual data points. The actual personal information is removed, but still it's individual medical data, so it still have to comply with all this privacy regulations. And then we have this database, which is a single file. And at our container solution, which is Red Hat's OpenShift, it's connected to Kubernetes, we can add a persistent storage to a container. And what we do is that we copy this database to that persistent storage of that container. And when the container starts, it's actually mounting this persistent storage file directory, and then it can access the database. So this is a bit how it works.
And the next question was, which is the main advantage of keeping it all in R with Shiny instead of using Streamlit, Power BI, or Tableau, for example? Did you feel you were at any point sacrificing on simplicity?
Well, no, I understand where this question is coming from. Like maybe it's easier to build a dashboard using Power BI. This could be the case, but however, we had the skills to build an R Shiny application, and this is the interesting part. Now, I started working with R Shiny with 2 new members of the team that does the data preparation. These were people that are skilled in R, but not so much in R Shiny. And we managed to build a new application from scratch within, let's say, 2 months. So with no experience, we got to create an application in R Shiny within 2 months. And this was part-time. This was a couple of hours a week that we were working on this. So it is not as hard as you might think. The advantages of having the same language through the entire analytics pipeline vastly outweigh the complexity of creating an R Shiny application. It does take some getting used to the idea of modularization. And obviously there are a couple of questions that you really need to wrap your mind around, but once you get there, it's very doable, especially if you have R skills and you work in tidyverse. Then yeah, as I said, it's the advantages vastly outweigh the disadvantages here.
Thank you. And lefters, I see you asked a question on Slido too. So if you want to jump in, please feel free to do so. But the question was, did you use any specific method to increase the performance of your application? And did you scope your data or load it all in the global file?
Yeah, now considering the performance, of course we used we profiled the application while it was running. And, yeah, with Profis, and just see what are the things that just take most of the time, and it usually means the first step where you have to load the data from the database into memory so the user can work with it. By using a database, it also means that you can have most of the data just on file, and you just use a query using a dbplyr and only collect the data you want to use. And that's actually when somebody logs in, it only gets the data from that specific region, and that's actually the data frame you're working with most of the time in the database. In short, we have quite a large database, and now we have about 10,000 of infections each day. So it's getting actually bigger and bigger and bigger. So you also see that the applications get a little bit slower. But as soon as the data is loaded, then the application is as fast as always. So that's the. So what we do is that we select the data from the database. Only the selected data is put in some. I'm not even sure it's in a global. I think we use a global data frame for certain visualizations. Some are selected at the level of a module. It depends.
Mm-hmm.
So
thank you.
when we started off, I thought like 5 seconds loading time is too much. It needs to be instant. I think we passed 5 seconds now for some visualizations, and we probably could do better with React log and Profis. But in all honesty, it's like sometimes the metaphor is like, when are you gonna change the wheels on the bus when you're going over the highway at 130 miles an hour? So it's quite difficult to optimize at this moment. But in all honesty, I think this does deserve a little bit more attention from us.
A question that I wanted to ask earlier too was around the prototype that you built and the process that you went through, because I feel like that was so important for getting everybody on board. Was that was shared to Shiny Apps IO, or what was the process from doing that?
Well, I created it just in our studio in the month of December. I did some work on our Shiny before I started working at the RIVM, so I had a lot of code already sitting there ready to be used. So that was very helpful. So I think I created this in, I don't know, maybe a week or so. And then we put it on shinyapps.io just for some, no, I didn't even put it on shinyapps.io. I just ran it locally and showed it to people. I was just sitting in my office, waving at people, wanting to, telling them to come in and take a look at the application. And afterwards, we put it on shinyapps.io and we could show it to more people. But yeah, a bit of improvisation there.
Cool.
And this application, this was a demo application containing fake data, of course.
Obviously, yeah.
But I see Dan also asked a question through Slido that was, how did you make sure regions and users felt comfortable using your app? So you're not just fielding questions that are answered within the app.
Yeah, that's a really good question. I think it helps that we are from the National Institute. I think that really helps because we are a trusted institute, and the municipal health services, I think, have a good relationship with our organization. So that helped. And also giving the presentations, just showing the people that that we were working very, very hard in order to create valuable insights for them, and not just assume that they will find the application. Go to them, put in effort, and earn the trust. I think that was also really important. Yeah, but it was not necessarily a given that they trusted our application at all times. Yeah.
Thank you. And a few of the other questions, just going through one, a few more technical ones about Docker. Let's see, one upvoted one was, what types of businesses are hotbeds for COVID clusters? Has this information informed policy changes by people who have used it?
That's a good question. So there's a lot of data being collected on clusters, and some of this is presented in the Clusterbuster, not all of it, but all of it is used in our, how do you say this, National Council, National Advisory Board on COVID. And they definitely use this data to, in our models, they use this data to form policies surrounding the battling COVID-19. But this was not so public policy making on a national level was not influenced by the Clusterbuster, but on a local level, it was in a way influenced. Think, for example, of the allocation of these mobile vaccination units. I think that's a good example. So that's one very practical thing that they use the Clusterbuster for, to optimize. But they were not opening schools because the Clusterbuster said it was safe to do so. It didn't go like that.
Tom Fowler, I see you just put a question into the chat if you'd like to jump in.
Yeah, thanks.
Yes, I got someone.
Yeah,
Hi.
great presentation, guys. Thank you. That was
Thanks.
really interesting. You mentioned towards the start that some of the data quality issues improved over the course of the rollout engagement with your users. Great to know a little bit more about that. That's
All right.
obviously good data in helps create good output, and bad
Yeah.
data in isn't great.
No, exactly. So this was, as I said, like a side effect, but a very important one for us. So one of the examples is that when they were writing down the clusters, they sometimes forgot to add the postal code, which was something that we used to give a cluster a location on a map. So at one point, one of the MHSs contacted me and said, well, we don't see any visualizations of our clusters, but they were not giving us the information to do so. So then we had a conversation about what we were missing, and then they started filling out the postal code. So they were improving their data quality, and that helped us to give them back the insights. Another example is that they were using a software program to do all their registrations, but at some point they have to click an option that says send this to the RIVM, and they were not always doing that. So we actually put up a notice on the dashboard saying, if you want to have these insights, make sure that you actually activate that button. And a lot of them actually started doing better in that regard.
Yeah, great. It's that feedback loop that I think is really important, that always needs to be called out. Great, thanks everyone.
Definitely, yeah, definitely. So obviously one of the questions that they ask is, why do we need to register this? We are already very, very busy. What's the use of us putting this specific detail down? And by providing insights, they got a part of the answer on that question. Like, this is why you do it. And oftentimes that would help them in their motivation, obviously.
Yeah, but I think this is a question for you. It said, maybe I missed it, but did you use a CI/CD for the Shiny Docker Kubernetes workflow?
Yeah, that's what we did. I think I forgot to mention it, but as soon as we update one of the testing, accept, or production versions in our Git environment, it immediately kicks off a new rebuild of the container. So this is what I call continuous deployment, the continuous integration. For example, with integration tests, I love to do that, but we haven't done it yet.
Thank you. Two other questions that were there on Slido. And again, if there is a burning question that I missed from the chat window on Zoom, to jump in. But it is, did you have any functionality within your apps to send individual level data to municipalities?
No. No, we didn't. So we added a download button at a specific point in our dashboard, but we were very wary of providing options to download the data for obvious reasons. You don't want this data to just float around. So we limited the sharing of personal data. There are other options in which the MHSs can get more detailed information from the RIVM, but most of them already have it. So no, through the Clusterbuster, we were not really providing any personal details. This was also not the point of the Clusterbuster. So the point of the Clusterbuster was to help doctors and epidemiologists gain an understanding of the COVID-19 situation. And the numbers were so great, the individual level was not important.
I see Fernando just asked in the chat if you have some resources on using modules in Shiny, and that can be a question for anyone on the call if you have any resources you want to share in the chat.
I think there are on the RStudio website some blog articles. There are very good resources. That's how I started also. On YouTube, you find some our user conference, of our studio conference presentations about Shiny modules. So there's plenty of information about it, and the most important thing is just try. It's Shiny models. When you start, it's a bit difficult to wrap your head around, but as soon as you get it, then it's getting easier and easier. But just try and ask around, of course, if you don't know what to do.
definitely. One of the last questions I saw in Slido was, for huge amounts of data, how do you test it out file types like RDA or Parquet to store your data set within your containers?
It's not for Clusterbuster. We have other applications with huge files with many data where it's a concern. But we started with Clusterbuster. The current way of using SQLite was fast enough. Now we're running into situations that we think, well, might be faster. Getting it faster would be nice. But for other applications, we want to look into it. But it's very depending on the type of data and how you use it in your application. So actually, when you're starting off, it's always good to think about it and do some tests. And it really depends on what you want to do with your data.
Thank you. And thank you for answering all of these questions too. I know I'm throwing a lot of questions at you, and we're getting right until the end of time here. So I'd love to just ask one more question for people who are on the call who are maybe in this position of just starting to use Shiny, or they have this idea of something that could help the business or organization. What is one piece of feedback you would give them for just getting started with that first project?
Start small. Just take something relatively simple, make it look good. Once again, I'm sorry to emphasize this, but it is important. If you want to convince decision makers, then definitely do so. But start out with something small. And this is one of the reasons why we are working towards making something open source, because I think we can help you guys get a head start with this. I really hope we can help you guys. So more data-driven healthcare is always good. But yeah, just start with something small. Make sure it looks good, it works good, and use that to convince your decision makers.
Awesome, thank you. Job, do you have anything else to add, or a tip you would give people?
No, I think at least if you work at a big corporate or an institute like us, go talk with your IT department. Just discuss things, what you want, and try to find solutions. But keep an open mind and keep an open talk with these guys. And finally, you will find something which works for everybody. So.
Maybe one last thing to add, and there is a great blog on this on the website of RStudio, I believe it was, on why a code-first approach is a good thing to do. And I think it's really wise to read through this and understand the reasoning behind this, because a code-first approach really does help. For example, if you want to open source the way you work, well, you need code. Code is reproducible. For quality assurance and quality control, code is a good thing to have. So there are a couple of very convincing reasons to work with a code-first approach. But go read the blog, and I think that will give you some background into our arguments for this as well.
Thank you. I think I put the right one there. I know there's a few different ones on Code First, but I'll try and gather all the resources that were shared in the chat too when I share the recording. And we'll share the slides there too. I just want to say thank you so much to both of you for the awesome presentations and just being so open with us and sharing all that you learned. I really appreciate it. And thank you all for joining too. It's great to see all the amazing questions.
Well, thanks for the opportunity. It was a pleasure.
Thank you very much. Yeah, indeed, my pleasure.